This section covers problem solving. In this presentation, you will determine what type of problem solving strategy you use in order to find solution to problem. Then towards the end of this discussion, we're going to take a problem and dissect it to its parts. The parts are the given, the operation, and the goal. We will see how we can look at each one of these in order to come up with the best strategy to solve a problem. Einstein said it best: we can't solve problems by using the same kind of thinking we used when we created them. In other words, Einstein told us to think outside of the box. As scientists, we are excellent problem solvers. As a problem solver, scientists must understand all parts of the problems to arrive at the correct solution. Solutions can be arrived by one of two ways: either through divergent thinking, which leads to divergent solution, or convergent thinking, which leads to convergent solution. Divergent thinking involves generating a list of ideas, free-flowing open discussions, and then seeking diverse solutions. One of them might work. Convergent thinking, on the other hand, means sorting ideas into categories, summarizing key points, and then coming up with a solution that most likely will work. So, what type of problem-solving style do you use? Consider the following 9 questions. Take scores of whether you answer the questions A or B and tally it up at the end. Question 1. I prefer to solve most problems A, by relying on a logical approach, B, by relying on hunches and inspiration. Question 2. Most problems can be solved by A, step-by-step process of elimination, B, trying out all the possible solutions which comes to mind. Number 3. I think people should solve problems by A, careful analysis. You cannot afford to overlook details. B, thinking up a large number of possible solutions. One might work. Question 4. If searching for an address in a strange city, I would sooner A, look it up on a street journal, or B, ask a local resident how to get there. Question 5. If told I must follow one of two professions, I would sooner be A, a mathematician, B, an advertising copywriter. Question 6. If I have mislaid something, I usually A, search methodically through every possible hiding place until it comes to light, or B, first think of the places it might be and then check them out. Number 7. If asked for advice, I usually A, offer a few carefully considered questions which are almost certain to work, or B, come up with a large number of suggestions which may or may not work. Number 8. When seeking the answers to a problem, I am most successful A, working towards a solution on my own, or B, exchanging ideas as part of a team. Finally, the 9th question. When a piece of equipment breaks down, the best way of fixing it is to A, take it apart, component by component, until the fault is found, or B, get a general idea of what might have gone wrong before trying out suitable repairs. So tally up your A's and B's. Response to this assessment. Before revealing your personality solving style, consider the following situation in which finding the solution fast may literally be a matter of life and death. So, what type of problem solver are you? Generally, there are two types of problem solvers: pathfinders and helicopter pilot. The name arrives from a scenario that was presented in terms of how people try to find lost uh, hikers in the forest or in the terrain. Consider the scenario in which a boy gets lost in the woods. Of course, his parents are worried, and so they send out a search party. One search party involves pathfinders. They will go to the last location where the boy was seen and then inspect closely where that boy could have gone. They would look under every brush, look at taverns, and then try and comb the area in as much detail as possible. Of course, they're going to be limited in their search area because they can only cover so much ground. And then there's the second search party that involves taking an aerial view of the land. We call them helicopter pilots. They're going to scan the terrain and they're not going to be able to see the details, but they'll be able to cover as much ground, more ground than the pathfinders. So, which preferred problem solving style are you? Are you a pathfinder who work their way systematically through the task until they arrive at a solution? Or are you a helicopter pilot who prefers to take a far more general view of the task and are less concerned with being methodical? Well, pathfinders, in the survey, if you scored 5 or more A's on the assessment, then the pathfinder approach is your preferred mode. This means a strategy of carefulness, patience, logic, general intolerance of uncertainty, with a dislike for hunches, ambiguity, and guesswork while seeking solutions. When faced with a problem of any type, information provided is analyzed in meticulous detail and proceeds systematically from one conclusion to the next in seeking the answer. Helicopter pilot. In the survey, if you score 5 or more B's, then this strategy is preferred. This style is more intuitive and less systematic in approach than the Pathfinder. The approaches take a broad view of the task and proceed by intuition more than analysis. The available information is scanned rapidly and a number of possible solutions arrive at quickly, which can then be put to the test. By taking a wider view, the solutions may be more rapidly reached than the methodic Pathfinder. The risk of missing an important point of overlooking essential details is the main risk of this approach. So, let's dissect a problem. Understanding and analyzing the problem. All problems, whether convergent or divergent, simple or complex, are constructed from 3 basic components. These have been identified as the given, the operation, and the goal. In order to understand a problem correctly, the essential first step towards finding the answer by a fast, consistently reliable route, one must identify these components and appreciate their full implication. A frequent cause of wrong answers and confused thinking is an initial failure to realize fully how problems are put together. Let's take a look at the given. Consider the question: a candle is 15 inches long and its shadow is 45 inches longer. How many times is the shadow longer than the candle? If you said 3, then you're wrong. Read that question again. A failure to understand the given is a common source of mistake. It may occur because some aspect of the information provided is overlooked, as in the problem above, or because an essential given is not stated or even indirectly implied but assumed from general knowledge of the subject or prior knowledge of the subject. So if we go back to the candle, the key operative word there is the word longer. Read that sentence. A candle is 15 inches long and its shadow is 45 inches longer. In other words, 45 plus 15, it's 60 inches long, which makes the shadow 4 times longer than the candle. Again, that occurs a lot in chemistry. What happens is you overlook a keyword and then you start with the wrong assumption. Again, understanding the given. Consider the second scenario. 2 men on bicycles face each other down a long, straight track 20 miles apart. At exactly the same moment, they begin to cycle towards one another, each maintaining a speed of precisely 10 miles per hour. As they move off, a fly on the handlebar of one bicycle takes off and flies to the second bike, then immediately returns to the first. The fly continues in this way, flying to and fro along an ever-decreasing distance at 45 miles per hour. Assuming that no time is lost in turning around at the bike, how far will the fly have flown when the cyclists meet? Now, if you think about this problem, you might think that, wow, that's really hard, because you got to calculate how far the bicyclists travel while the fly is traveling, and probably to do some sort of calculus. But really, the problem isn't really that difficult. I'll come back with the correct answer towards the end of this discussion. But give this a few moments. Pause the tape here and think about how you would solve this problem. Again, the subject of this particular slide is understand the given. Let's take a look at the operation. What is the operation? These are the methods by which information provided by the givens may be moved around. As a general rule, it pays to be flexible in your thinking when coming up with suitable operation, as a major stumbling block to success is a form of tunnel vision that sets the mind in an intellectual rut and causes it to try and solve the problems by familiar but, on occasion, inappropriate tactics. For example, if you were given 6 matchsticks and told to form 4 equal-sided triangles from them, would you need to identify the type of operation in order to produce an answer? Think about that. The problem again is presented towards the bottom of this slide. But before you do so, where certain problems are concerned, both given and operation may be overlooked due to a form of mental blindness, which psychologists call a set. Read this statement. Did you read Paris in the spring? Or did you read Paris in the spring? If you notice, there's 2 the here. In our way of trying to read fast, our brain already shuts down the second the because it's illogical. Again, you're overlooking the given and proceeding with an operation that's incorrect. Let's go back to the match problem. Given 6 matchsticks, how can 4 triangles be formed, all the sides of the triangle being equal? I've given you a start. There's 1, 2, 3, 4, 5, 6 matchsticks right here. And there are 1, 2, 3, 4, 5, 6. But you can see that only 2 equilateral triangle is generated by this formation. The third is incomplete, and this does not even come close to 4. If you take this matchstick and you dissect it right through here, then you don't have an equilateral triangle, and this matchstick would be too short to make it all the way to that end. So again, how would you solve this problem? If you have the solutions, congratulations. You thought outside of the box. What you need to do in this particular problem is not limit your mindset to 2 dimensions. You actually have to use the 3rd dimension. And by doing so, you make a pyramid. A pyramid has 1, 2, 3 in the opposite side, and 4 in the bottom, equilateral triangles from 6 matchsticks or 6 sticks. Again, you have to think outside of the box. You have to think about your operation. Now, let's talk about the goal, restating the goal. With some kind of problems, however, a solution can only be found by restating the goal in different terms. This is especially true for divergent tasks, where you may find it impossible to devise satisfactory operation for achieving one sort of goal, but have no difficulty at all if you can reformulate what needs to be done. Consider this scenario. A wealthy merchant had 2 sons who pride themselves on their horsemanship and the speed of their stallion. Each boasted that their mount was superior to the other, and his skill in the saddle outshone the ability of their brother. At the length, the merchant grew so tired of listening to their arguments that he offered a wager. To settle once and for all, his fortune would be bequeathed to whichever of the young men won a race from his palace to the city some 100 miles across the desert. But it was to be a most unusual race, for instead of the prize going to the man whose horse reached the city gates first, it would go to the son whose mount was last. The riders set off, each traveling as slowly as possible, so that after several days they were still only a few hundred yards from the father's home, and it seems likely the race would last forever. Indeed, such might have been the case, but the arrival of a wise man who, after being told of the nature of the problem, was able to give the men some sound advice. Seconds later, they were galloping towards the city as fast as their mounts could carry them. So, what words of wisdom did the old man offer? If you have the answer, congratulations. You were able to reformulate the goal so that the problem could be solved. The solution is really simple. And again, it requires you to read the question and realize that the wager was whose mount was last. And so what the wise man told the sons was switch horses, and their mount would be last if they won the race. Pretty clever, don't you think? So, when solving problems, there are generally 5 steps. Identify the problem, read the questions carefully, and write down precisely what is wanted. You have a given, you have an operation, and you have a goal. Your job is to make that connection. Collect and write down the data and known facts related to the problem. This also requires writing any previous knowledge given information that you will need. Analyze the data, identify the type of problem to be solved, and set up the problem by outlining a specific plan or pathway to the answer. This will be your strategy of what operation to use. Carry out the proposed plan to a tentative solution. This is always important, especially in science, because you want a tentative solution and see whether that solution makes sense. If the question is, you're heating up water and you start at, say, 20 degrees and you increase the 20 degrees Celsius, that is, and you put in, say, 500 calories, what is the final temperature of the water? Given that you have maybe 1 liter. If you come up with an answer of 5,000 degrees Celsius, that's pretty absurd, because 5,000 degrees Celsius, somewhere in the order of about 6,000, somewhere a little under 6,000 degrees Fahrenheit. And of course, water would boil way before then. So think about your tentative solution and see whether it is in the ballpark. See whether it makes sense. Evaluate finally the 5th part of solving problems, evaluate your answer to make sure it is reasonable solution. If it's not, cycle through these steps again. So that concludes this particular PowerPoint slide on your type of problem solving strategy and dissecting problems based on the given, the operation, and the goal. Let's go back to that problem with the bicyclist. Let's consider this problem again. What's happening is that the two bicyclists are 20 miles apart and they're maintaining speed of 10 miles per hour. Of course, if they're 20 miles apart and they're going 10 miles per hour, then they meet precisely in the center in 1 hour. That should be enough information to let you know how far the fly has flown. If the fly is flying 45 miles per hour, then the total distance that fly will have flown back and forth would be 45 miles.